chapter and very important chapter in our course, giants. Most of the interviewers, they start questioning from giants topic. Most of the interviewers, they start questioning from giants topic because most of the students feel this as tough topic. So that is why interviewer starts questioning from this topic. And this is very, very important for cracking interview questions as well as real-time job also. So chapter name is giants. Okay, Jan means joining, combining, joining, combining, connecting, linking. Any meaning you can take. Jan means joining, combining, connecting, linking. Any meaning you can take. That's the general meaning. So what is Jan? Jan is an operation. What is Jan? Jan is an operation. Okay, just like sort, sorting. Sorting is an operation. Filtering is an operation. You already know this. To perform sorting, we use order by class. To perform filtering, we use where class. Order by price, ascending order. Order by rating, descending order. So what is sorting? Sorting is an operation. In sorting operation, what it is doing? Arranging records in ascending or descending order. What is filtering? Filtering is an operation. In filtering operation, what it is doing? Okay, it filters the rows. It filters the rows. Just like sorting is an operation. In sorting operation, it is arranging records in ascending or descending order. What is filtering? Filtering is an operation. In filtering operation, it filters the rows. Select specific rows. In the same way, what is Jan? Jan is an operation. In Jan operation, what it is doing? One table row joining with another table row. This is Jan operation. One table row joining with, combining with, connecting with another table row. This operation is called Jan operation. Simple. Once again, I'm telling, sorting is an operation. What is sorting? Sorting is an operation. In sorting operation, what it is doing? Arranging records in ascending or descending order. What is filtering? Filtering is an operation. In filtering operation, what it is doing? Selecting specific rows. In the same way, what is Jan? Jan is an operation. In Jan operation, what it is doing? One table row joining with another table row based on some condition. Based on some condition, it is joining. Based on some condition, it is joining. That condition is called join condition. So based on this join condition, one table row joined with another table row. This is called join operation. In join operation, one table row will be joined with another table row based on join condition. Join is an operation. In join operation, one table row will be joined with another table row based on join condition. Then why we are joining like this? One table row, why we are joining with another table row? Because we want to access second table data. To access this second table data, we need to perform this join operation. So the main purpose of joins concept is, it is used to retrieve the data from multiple tables. Joins concept is used to retrieve the data from multiple tables. If we want to get data from multiple tables, definitely we have to go for joins. This is the main purpose of joins. If anyone is asking why join, tell this one. This joins concept is Use it to retrieve the data from multiple tables. If you want to get data from multiple tables, go for giants. So 2 points I told, sir. First point, what is giant? Second point, why giant? First point, what is giant? Second point, why giant? 2 points I told. What is giant? It is an operation. In giant operation, what it is doing? One table row joining with another table row based on giant condition. This is called giant. Why giant? If we want to get data from multiple tables to access this second table data, first table row we are joining with second table row. So with this we get data from multiple tables. To get data from multiple tables, we are using giant's concept. So database contains multiple tables. If you take college database contains, college is offering courses, course details. They are maintaining in course table. Their student details they are maintaining in student table. Their marks details they are maintaining in marks table. Their fee details they are maintaining in fee table, like this. A database contains multiple tables like this. Sometimes we need to get data from multiple tables. So to get data from multiple tables, we are using the concept giants. Giants concept is used to get the data from multiple tables. See one example on it. This is student table, student ID, student name, student address, contact number, etc. Student basic information is there. This is marks table. It has students marks details. Subject 1 marks, subject to 2 marks, subject to 3 marks. Next. For easy understanding purpose, I am giving subject names as maths, physics, and chemistry. Understand now? 1001 student, A student is from Hyderabad. 1002 B student is from Bangalore. Like this data is there. Student details are available in the student table. Their marks details available in the marks table. 1001 student got 17 maths, 16 physics, 85 in chemistry. 1002 student, 56 in maths, 44 in physics, in chemistry 30. Like this. Like this data is. Understand, sir? One college is maintaining their database in the form of tables using Oracle like this. In the form of tables, they are maintaining the data. They are maintaining student details in the student table, their marks details in the marks table. Now, this maths faculty is asking that he wants students' details along with maths subject marks. Who is asking output like this? Maths faculty. This maths faculty is asking that he wants student details along with their maths marks. So the student details are available in student table. This maths marks available in marks table. Now we need to get data from multiple tables. To get data from multiple tables, go for giants. This is the purpose of giants. If anyone is asking why giant, tell this point. To get data from multiple tables. Okay. So till now, we retrieve data from one table only. Suppose I want to get output like this. SID, SNAME, SCT I want. I want to get data from one table. To get data from one table, giants are not required. Just write select star from student, enough. But I want to get math subject marks here. This SID, SNAME columns available in student table. This maths column available in marks table. This SID, SNAME columns available in student table. This maths column available in marks table. So from two tables, I want to get the data. If we want to get data from multiple tables like this, definitely we have to go for the concept giants. Giants concept is used to retrieve the data from multiple tables. This is the purpose. How it performs join operation? Observe now. Listen. To perform join operation, common column is required, sir. In student table and marks table, which one is the common column? In student table and marks table, which one is the common column? SID. If this SID is not there, it is meaningless or not? Meaningless, observe. These are 70 mass marks of which student? You cannot I understand now. Meaningless data, sir. So for join operation, common column is required. What is that common column? SID, student ID, common column. So if student table SID is equals to marks table SID, then join them. You tell me, sir. I'm asking one simple question. Tell me. Okay. This A student got how many marks in maths? A student got how many marks in maths? 70. How you are telling? How you are telling? Based on SID. This student table SID, marks table SID, both are equal. That is why you guessed A got 70 marks. Once again, I'm telling. Just now I asked one simple question. This A student got how many marks in maths I asked. Then immediately you told 70. How you told? Based on the student ID. Okay, the student table student ID, marks table student ID, both are same. That is why you guessed this 70 is marks of A student. Same thing Oracle has to do. If student table student ID is equals to marks table student ID, join them. So student table SID, if it is equals to marks table SID, then join them. So I'm writing like this. SID equals to SID. Can we write like this, sir? Can we write like this? No. Why? This is not clear instruction. Which SID you are comparing with which SID? Oracle cannot understand now. Do you want to compare student table student ID with another student ID in the student table? Or do you want to compare marks table student ID with another student ID in the marks table? Or do you want to compare student table SID with marks table SID? Which SID you are comparing with which SID? This is not clear instruction. You cannot write like that. That is why to identify this one uniquely, to identify this SID column uniquely, your column name is same. That is why you cannot write like this. To identify this column uniquely, take the help of table name. Table name is student. So write student dot SID. Table name dot column name. Write like this. Student dot SID equals to marks dot SID. Now it works. If student table student ID equals to marks table SID, then join them. So in real time, table names may be lengthy. Suppose this table name is not student. This table name is Hyderabad branch employee details. Suppose example, Hyderabad branch student details. Assume. Now what I have to write here? Hyderabad branch student details dot SID. It is becoming lengthy. To make it short, we use table alias. For student table, I'm giving alias name as S. So I have no need to write this many characters. Just I can type S. Just this lengthy name, I'm making short. This lengthy name, I'm making short M. So write S dot SID equals to M dot SID. This is called giant condition, sir. This is giant condition. This is giant condition. Okay. Why I am writing this giant condition only? Because just apply the common sense. I asked that A student got how many marks in maths? Immediately I told 70. How you are telling? Based on student ID. Same thing Oracle has to do. If student table SID equals to marks table SID, join them. Why we are joining? If we join like this, I can access mass marks, physics marks, chemistry marks. I can access second table data. To access second table data, perform join operation. That's it. Now how it works, understand now. S dot SID takes 1001. Is it equals to 1001 or not? It checks. If equal, joins. Otherwise, will not. Is 1001 equals to 1002? No, will not. Next 1002. Is it equals to 1001? No. Next 1002. Is 1002 equals to 1002? Yes. Yeah, like this. So student table SID compares with every student ID in the marks table. If equal, join. Otherwise, will not join. Next, it takes another student ID in the student table, compares with every student ID in the marks table. If equal, joins. Otherwise, will not join. Like this, it performs join operation. Notice here. Student table SID. Okay, till here. Once again, I am telling, listen. What is join? It is an operation. In join operation, what it will do? One table row, it joins with another table row based on join condition. This is called join operation. Why we are joining like this? To retrieve data from multiple tables. So this joins concept is used to retrieve the data from multiple tables. For example, one college is maintaining their database in the form of tables like this. Their student details they are maintaining in student table. Their marks details they are maintaining in marks table. This maths faculty asking that he wants this data. Student details with maths marks. So to get data, student details are available in student table. Maths marks are available in marks table. To get data from multiple tables, I am using the concept joins. So for performing join operation, common column is required. Common column is student ID. Okay, just now I asked that a student got how many marks in maths? You told 70. Same thing Oracle has to do. If student table SID equals to marks table SID, join them. That is why I'm writing this condition. So we cannot write SID equals to SID. We cannot write like this because same column name is there. That is why to identify this SID, we are prefixing with table name. To identify this SID uniquely, we are prefixing with table name. Student table SID, if equals to marks table SID, join them. But in real time, table names may be lengthy. To make this short, we use table alias. For student table, I am giving alias name as S. For marks table, I am giving alias name as M. S dot SID equals to M dot SID. Now, how it is performing join operation? Observe. Student table SID it is taking 1001. S dot SID value 1001. Is it equals to M dot SID value or not? It is checking. Is it equals to 1001 or not? It is checking. Is 1001 equals to 1001? Yes, true. So it performs join operation. Student table row joined with marks table row like this. This is called join operation. Student table SID equals to marks table SID, then join them. This is called join operation. If we join like this, I can access math marks, physics marks, chemistry marks. I can access second table data. To access second table data, I am performing this join operation. This is called join operation, sir. One table row joined with another table row based on this join condition. This is called join operation. With this, I can get the data from multiple tables. 1001, a student got 70 marks. Logically, here to here, it treats as one row. Logically, join is logical operation, not physical join. Logical. That's it, sir. Next, is 1001 equals to 1002 or not? It is checking. S dot SID value 1001. Is it equals to 1002 or not? It is checking. False. Will not. Next, it takes 1002. S dot SID value 1002. Is it equals to 1001? It is checking. False. Will not there. Is 1002 equals to 1002? It checks true. Giants now. Giants like this. Like this is giants. So this is called Jan operation. So if we Jan like this, now we can get the data from multiple tables. So this is about Jan. 2 points I told. What is Jan? Okay, what is Jan? Operation. If anyone is asking what is Jan, tell this one. Operation. Jan is an operation. In this, what it is doing? One table row joining with another table row based on join condition. What is the purpose of it? To retrieve data from multiple tables. Okay. So some students unable to tell one sentences also. Why I don't know. You should not be among such kind of idiot. If anyone is asking what is Jan, tell this one. Jan is an operation. In Jan operation, one table row will be joined with another table row based on Jan condition. In this example, this student table row joined with marks table row based on this condition. If student table SID is equals to marks table SID, then joining. If we join like this, but the advantage we are getting, we can get data from multiple tables. To retrieve data from multiple tables, we are using join. So this is telling that why join. 2 points I told. Is it clear about these 2 points? What is join? Why join? Is it clear? Online students, please confirm. Is it clear about these 2 points? Online students, please all of you confirm in the chat box. Did you understand the purpose of? Okay. Now we know 2 points very clearly. Jan is an operation. In this, one table row will be joined with another table row based on some condition. This is Jan. To get data from multiple tables, we are using Jans. Okay. Now see different types of Jans. If we know these types of Jans, we know Jans. That's it. Okay. Different types of Jans are there. Mainly 4 types are there. First one is inner Jan. Second one is outer Jan. Third one is self Jan. And fourth one is cross Jan. Cross Jan. These are the 4 types of Jans. In this cross Jan can be also called as Cartesian Jan. Cartesian Jan. If anyone is asking what is Cartesian Jan means, you should not get confused. Cross Jan is asking. Self Jan can be also called as recursive Jan. Recursive Jan means self Jan only. These are the 4 types of Jans. In the inner Jan, 2 subtypes are there. What are those? Equijan, non-equijan. In the outer Jan, 3 subtypes are there. What are those? Left outer Jan, right outer Jan, and full outer Jan. That's it. If we know these things, we know Jans, sir. Very easy. Very, very easy. How many types of Jans are there? 4 types. What are those? Inner Jan. Second one, outer Jan. Third one, self Jan. It can be also called as recursive Jan. Fourth one, cross Jan. In the inner Jan, again 2 types are there. Equijan, non-equijan. In the outer Jan, 3 subtypes are there. Left outer Jan, right outer Jan, full outer Jan. Shortly you can say left Jan, right Jan, full Jan. These are the different types of Jans. What is inner Jan? Inner Jan gives matched records. Simple. Inner Jan is equals to matched records. Inner Jan gives matched records only. What is outer Jan? Outer Jan gives both matched records and unmatched records. What is inner Jan? Inner Jan gives only matched records. What is outer Jan? Outer Jan gives both matched records and unmatched records. Now we need to understand the term. What is this matched? What is this unmatched? Understand this? For example, the same example I'm taking. There is a student is there, 1003 C student. He is from Chennai. He was absent to the exams. The student was absent to all exams. So because of he is absent, okay, I didn't enter his marks details here. Now notice here, for first record 1001, matching record available in another table. For 1001 record, matching record is available in another table. So that is why this first record is called matched record. This is matched record from student table, and vice versa. This is student, this is matched record from marks table. For one record, if matching record is available in another table, that is matched record. Second record also matched record. For 1002 record, matching record available in marks table. So this is matched record. Matched record. And vice versa. From marks table to student table, this record has matching record available in student table. So this is matched record from marks table. So inner join can give this matched records only. This is unmatched record. For 1003 record, there is no matching record available in another table. So inner join can give this matched records only. Inner join equals to matched records. Inner join can never give unmatched records. But sometimes we need to get these unmatched records also. I want to get student details with marks details. Who are absent also I want. Absentees are in student table. So absentees also I want. So unmatched records also I want. If we want to get unmatched records also, go for outer join. Outer join gives both matched records and unmatched records. So this is match record for 1001. Matching record available in another table. For one record, if matching record is available in another table, that is called matched record. For one record, if matching record is not available in another table, that is called unmatched record. We should know this one, sir. Match that match. For one record, if matching record is available in another table, matched record. For one record, if matching record is not available in another table, unmatched record. So inner join gives matched records only. Outer join gives both matched records and unmatched records. Inner join. Inner join is equals to matched record. Simple. It gives matched records only. Inner join can give matched records only. Okay, it has two subtypes. It has two subtypes. What are those two subtypes? First one is equijoin. Second one is non-equijoin. Non-equijoin. So in today's session, completely we are focusing on equijoin. In all types of joins, the most important one is equijoin. First priority for equijoin. Second priority for outer joins. Third priority for self join. These are very, 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 very important. First priority for equijoin, second priority for outer join, third priority for self join. If interviewers want to test your knowledge on joins, they ask questions from these types of joins. First priority for equijoin, second priority for outer join, and third priority for self join. These are very, very important. Okay. Next, what is equijoin? Simple. The name is giving the meaning. I already told. Join means operation. Join means operation. One table row will be joined with another table row. If this join operation performed based on equality condition, that is equijoin. Simple. I already told join is an operation. In this one table row will be joined with another table row, I told. So to join one table row with another table row, if this join operation performed based on equality condition, that is equijoin. Suppose if I use greater than, non-equijoin. If I use less than, non-equijoin. Other than equal means non-equi. Equal means equi. Okay. Student table SID equals to marks table SID. Equijoin. Equality condition. This is equijoin. Based on equality condition, one table row joined with another table row. Equijoin. Suppose I am using greater than, other than equals to, non-equijoin. I'm using less than, non-equijoin. Less than or equals to, non-equijoin. Not equals to, non-equijoin. Other than equals to, non-equijoin. If I use equals, equijoin. If join operation is performed based on equality condition, then it is called equijoin. Just now I have given this example. If student table, student ID is equals, student table SID is equals to marks table SID, join them. Now this join operation performed based on equality condition. That is why it is called equijoin. Suppose I am writing greater than here. If student table SID is greater than marks table SID, join them. 1002 greater than 1001, join them. 1003 greater than 1002, join them. This is non-equijoin. Based on greater than condition, join operation performed. Greater than means other than equals to. Other than equals to means non-equijoin. If I use equals, equijoin. If I use other than equals, non-equijoin. That's it. Simple. So if join operation is performed based on equality condition, then we are calling that as equijoin. See first example on equijoin. This example only I'm taking. This is student table data. This is marks table data. The question is display student details along with maths subject marks. Is a question. So we want to get student details along with math subject marks. So we want to get output like this: SID, SNAME, maths. These SID, SNAME columns available in student table, alias name is. This maths column available in marks table, alias name M. This is my requirement. So for this, write like this: select two tables columns list. Select two tables columns list. Which columns we want to get? SID, SNAME, maths. After select, we give column list. SID, SNAME, maths. From which tables we want to get? Tell those two table names. Student table, marks table. Select two tables columns list. SID, SNAME, maths. From which tables we are retrieving? Student table, comma, marks table. Two table names. Where? Join condition. Okay. Can we write SID equals to SID like this? No. It gives output as error. Column ambiguously defined. SID ambiguously defined. This error we get. Because of same name, which SID you are comparing with which SID, it is not understanding. To solve this problem, prefix column name with table name. Prefix column name with table name. Student table SID compare with marks table SID. Now, does this query work, sir? No. Now, problem is not in the where. Now, the problem is in the select. Which SID you are retrieving? Student table SID, marks table SID. Again, it is getting confused. Previously, problem was there in the where. Which SID should be compared with which SID? This problem solved by prefixing column name with table name. Problem solved here. Where problem solved here by prefixing column name with table name. But problem is there in the select. Which SID you are selecting? Student table SID, marks table SID. Both tables are having SID. To solve this problem, again same solution. Prefix column name with table name. I want to get student table SID. So write student.sid, S name, maths. From which tables we are retrieving? Student, marks. Two table names. Where? Write giant condition. Student.sid equals to marks.sid. Does this query work? Yes, works. It works perfectly. But problem is there. It degrades performance. Above query degrades performance. How it degrades performance? Understand? For example, here maths column is there. Maths column available in which table, sir? Student table or marks table? Maths column available in which table, sir? Student table or marks table? Marks table. So assume that first Oracle is searching in the student table. First Oracle is searching in student table. Searching in student table. In student table, maths column available, not available. Then it is searching in marks table. In marks table, it is available. It is retrieving. So in how many tables it is searching? In two tables. In two tables, it is searching. In two tables, it is searching. So some time will be wasted here. To save this time, I want to tell this is the column of marks table. So prefix every column name with table name. For searching S name column, assume that first Oracle is searching in marks table, not available. Then Oracle is searching in student table, available, retrieves. Okay, in two tables it is searching. For maths column, assume that first it is searching in student table, not available. Then it is searching in marks table, available, retrieving. In how many tables it is searching? Two tables. I want to save this searching time. So prefix column name with table name. Directly S name column it searches in the student table only. If I prefix this mass with column table name, it searches in the marks table only. In one table only it is searching, time will be saved. It improves performance. So to improve performance, prefix column name with table name. Prefix column name with table name. But in real time, table names may be lengthy. For example, if table name is Hyderabad branch student details, we are write like this. Hyderabad branch student details dot SID, comma, Hyderabad branch student details dot S name. Like this. See here, these many characters I have to type. That is why to make lengthy name short, use table alias. For student table, give alias name as S. For marks table, give alias name as M. So write here S dot SID, S dot S name, M dot mass. Student S, comma, marks M. S is alias name of student, M is alias name of marks. Table alias. Here S dot SID equals to M dot SID. That's it. When we are writing Jan query, follow two rules, sir. Follow two rules. What are those two rules? Give table alias. Follow this rule. Prefix every column name with table name. Follow these two rules when you are writing Jan query. When we are writing Jan query, give table alias. Why we are giving table alias? We want to make lengthy name short. Student table name, short name I am making as S. Marks table name, short name I am giving as M. So here, no need to write student now, shortly I can write S dot SID, S dot S name, M dot max. From student S, marks M, where S dot SID equals to M dot SID. This is a final query. So S is alias name of student, M is alias name of marks. Prefix every column name with table name to improve the performance. Follow these rules. Whenever we are writing giant query, give table alias, prefix every column name with table. That one only I'm following. From which tables we want to retrieve? Student table, give alias name S. From marks table also I want to retrieve alias name M. I want to get student ID available in which table? S table, S dot S. I want to get student name available in which table? S table, student table, S dot S. I want to get mass column. Mass column available in which table? Marks table, M dot maths. Like this. Prefix column name with table name. Prefix column name with table name. Prefix column name with table name. Give table alias. Follow these two rules. Whenever we are writing giant query, give table alias. Prefix every column name with table name. It improves the performance. To make lengthy name short, table alias. To improve performance, prefix column name with table name. Where? Write giant condition. For giants, common column is required. Here, common column is SID. So write S dot SID equals to M dot SID. This is the final query. It works perfectly. So for your understanding purpose, step by step, I explained it, sir. So whatever I explained till now, this one only I want to show now. First, create these two tables now. Let me create two tables. Observe. First, create student table. First, create student table. Create table student. SID, number of 4. S name, varchar 2 of 10. SCT, char of 3. Bracket close, semicolon. Table create. Insert the records now. Insert into student values. Values. 1001 A HYD. First record. Comma. Second record. 1002 B Bangalore. Comma. Third record. 1003 C Chennai. First table ready. Create second table now. Create table marks. SID, number of 4. Maths, number of 3. Physics, number of 3. Chemistry, number of 3. Bracket close, semicolon. Marks table created. Okay, marks table created. Next, insert into marks values 1001 70 60 85. First student marks 1002 56 44 30. Second student marks. To save this data, write comment. Notice here, two tables are ready now. I'm opening two tables data. Observe here. select star from student. Observe, sir, student table is ready. Observe, student's basic information is there. Student details are available in student table. Select star from marks. Their marks details are available in marks table. This 1003 was absent. That is why his marks details are not available here. Unmatched record. Now, I want to get student ID, student name, and math subject marks. As per our discussion, step by step, I am showing. Observe. SID, SNAME columns available in student table. Mass column available in marks table. From two tables, I want to get the data. So I'm writing like this. Select two tables, columns list. SID, SNAME, maths. From which tables? Student table, comma, marks table. Where common column is SID. So SID equals to SID I'm writing. If I write like this, it gives error now. Because of same column name, which SID you are comparing with which SID? It is not understanding. In the where class, we get error. In the where class, we are getting error. Which SID you are comparing with which SID? It is not understanding. SID column ambiguously defined, it is telling. It is appearing in two tables, it is telling. It is available in marks table and student table. Which SID you are comparing with which SID? I am not understanding. I am getting confused. It is telling. Ambiguous means confusion. So to solve this problem, prefix column name with table name. So student table SID compare with marks table SID. Student.SID equals to marks.SID. Now where problem solved? Again same error I am getting, but now problem is in select. Where problem solved here? This SID column available in student table as well as marks table. Which SID it has to retrieve, it is not understanding. That is why SID column ambiguously defined, it is select. So to solve this problem, again same solution. I want to get student table SID. So write student.SID. S name maths. From which tables? Student table, marks table. Where student.SID equals to marks.SID. Now, does this query work, sir? Yes, it works perfectly working. But here one problem is there. For SNAME column, it may search in two tables. For mass column, it may search in two tables. Time will be wasted. To save that time, prefix every column name with table name. So I'm writing like this. Select student.sid, comma, student.sname, comma, marks.maths. From which tables? Student table, comma, marks table. Where student.sid equals to marks.sid. It is working perfectly. It improves performance also. It works faster. But problem is there. What is the problem? In real time, table names may be lengthy. If this table name is Hyderabad branch employee details, I have to write Hyderabad branch student details. If this table name is Hyderabad branch student details, I have to type like this: Hyderabad branch student details dot SID. Hyderabad branch student details dot S name. These many characters I have to type. Lengthy. That is why to make lengthy name short, use table alias. I want to get SID, S name, mass subject marks. SID, S name columns available in student table. Alias name I am giving as S. Mass column available in marks table. Give alias name as M. Tell me, sir, what is the final query? What we have tried? Select S.SID, comma, S.SName, comma, M.mass. Whenever we are writing giant query, prefix column name with table name. Use table alias also. What we have tried, sir? Select S.SID, S.SName. Okay, first is student Babu. See here. Select S dot student table. For student table, I am giving alias name S. For marks table, I am giving alias name M. SID, SNAME columns available in S table. Mass column available in marks table. So write like this, select S dot SID, S dot SNAME, M dot mass from student S, comma marks M, where write Jan condition as S dot SID equals to M dot SID, because common column is SID. If student table SID equals to marks table SID, Jan them. This is the query. This is my requirement, sir. Tell me now what we have tried. చెప్పాలి బాబు, అందరు చెప్పాలి. చెప్పాలనే నేను వరుతాను ఇక్కడ. చెప్పు బాబు. సెలెక్ట్ S dot SID, S dot SNAME, M dot mass from student S, comma marks M, where S dot SID equals to M dot SID. That's it, sir. This is the final query. Previous all are not important. This is important. Previous all for our understanding purpose I explained like that. This is final query. If you know this, you know equigen. You take any number of examples, same story will be there. Just tables will be different, data will be different, model same model. In real time, tables will be different, data will be different, but model is same. We are getting student details with mass object marks. This query works faster. That's it. Now, please confirm, sir. Did you understand this query? Online students, please confirm. Is it clear up to here? Till now, we retrieved from one table. Now we are retrieving from two tables. Very easy. Select two tables columns list. To improve performance, prefix column name with table. From two table names. From two table names. Two tables columns list. From two table names. Where? Jan condition. First, common column is required. It is performing Jan operation. That is why it is called equigen. Now, one more important point I'm telling. Pay attention, listen carefully. From Oracle 9a version onwards, we can write Jan query in two styles. What are those two styles? First one is Oracle style. Second one is ANSI style. ANSI style. Oracle style can be also called as native style, or you can say non-ANSI style. See, before Oracle 9a, only one style was there, Oracle style. In 9a, they added this ANSI style. Okay, this term is very important, sir. If any feature is ANSI, if any feature is following ANSI standard, with this we get one advantage. That advantage is portability. Portability feature will be there. Means in other RDBMS softwares also you can run. Portable means anywhere you can run. In any RDBMS you can run. If you write Jan query in ANSI style, same ANSI style Jan query, you can run in SQL Server, you can run in MySQL, you can run in DB2, you can run in any RDBMS software. That is the meaning of ANSI. If any feature is following ANSI standard, we get one advantage here. That is portability feature. ANSI prepared some standards. ANSI prepared some standards. You already know Oracle SQL is there. SQL Server SQL is also there. MySQL SQL is there. If any feature is following ANSI standard, means you can run in that ANSI standard. Okay, if any feature is following ANSI standard, that you can run in Oracle, that you can run in SQL Server, that you can run in MySQL. In any RDBMS you can run. That is the meaning of ANSI. ANSI means portability feature. We get common for any SQL. So that is why they added this ANSI style in the 9.9. Okay, so with this, learning Jan's concept is easier for us. Suppose in Oracle one kind of style, in SQL Server another kind of style, in MySQL another kind of style, in DB2 another kind of style. Now how many styles I have to learn now? 4 styles. It becomes complex. That is why what they did, they prepared one ANSI style. If we learn this ANSI style, same query I can use in Oracle, SQL Server, MySQL, DB2. Very easy. Tomorrow, when you are migrating from one database to another, easily you can run. And learning Jan's concept to developer is also becomes easier with ANSI style. That is why ANSI prepared some standards for getting portability feature. So in Oracle style and ANSI style, which one is the best way? ANSI style is best way. Why ANSI style is best way? ANSI style is portable. Portable means anywhere we can run. In any RDBMS software, we can run. Understand this one. Suppose this is a machine, sir, or this is a software, Oracle. Understand the meaning of ANSI. This is a software, bit software, Oracle. Okay, this is software, bit software, SQL Server. Suppose in the Oracle, I am developing Jan query. Assume that this circle is Jan query. Jan query. This is Jan query. This Jan query, I am developing in Oracle style. This Jan query, I am developing in Oracle style. I want to copy this to SQL Server and I want to run this one. Can we run, sir? We cannot give guarantee of that because this is Oracle style. Oracle style Jan query, I am trying to run in SQL Server. Can we run? We may not. We are not sure about it. Some queries we can run. Some queries we may not run. If you write Jan query in Oracle style, we cannot give guarantee of portability. Can we run this Jan query in the SQL Server? We may run, we may not run. We are not sure about it. We cannot give guarantee of it. But if we write this Jan query in ANSI style, we can give guarantee of portability. The same query I'm copying to SQL Server. Can we run here? Yes, we can run. We can give guarantee of it because this is which style? ANSI style. ANSI style means in any RDBMS you can run. If you write Jan query in ANSI style, in any RDBMS software, you can run. So that is why ANSI style is best way. If you know Oracle Jans means, you know SQL Server Jans also, MySQL Jans also, DB2 Jans also. Because ANSI style you can run in any RDBMS software. So if any feature is following ANSI standard like this, okay, for example, SID column, I'm declaring as number of 4. Understand, sir? Create table T1, F1 column, I'm declaring as number of 4. Bracket close. This query, I'm writing in Oracle. This same query, I'm copying to SQL Server. Okay, can we run there? No, it gives error. Because SQL Server is not providing number data type. Number data type available in Oracle. Number data type not available in SQL server. Suppose I'm declaring like this, numeric of 4. This numeric is ANSI data type. This is ANSI standard. Numeric is ANSI data type. So that is why the same query I'm copying in SQL server, I can run now. I developed this query in Oracle. Where I want to run this in SQL server. Can we run it? Yes. Because SQL server also providing numeric data type. Can we run in MySQL? Yes. MySQL also providing numeric data type. Can we run in DB2? Yes. DB2 also providing numeric data type. Like this. Numeric is ANSI data type. ANSI means portability will be there. If any feature is following ANSI standard in any RDBMS, that will be available. So that is why we should know about ANSI standards. If ANSI style will learn, the advantage is in any RDBMS we can run. So before Oracle 9.9, only one style was there, Oracle style. From 9.9 version onwards, we can write Jan query in Oracle style as well as ANSI style. So this ANSI style added in 9.9 version. I will explain both styles now. So the importance of ANSI style is portability. In any RDBMS you can run. Portable means anywhere you can run. Okay, just now we have written this query. Just now we have written this query. This is which style? Oracle style or ANSI style? Oracle style. Then how to write in ANSI style? Very easy. In ANSI style, observe here. Notice here. This is first table, sir. Student S. This is second table. You tell me now. In Oracle style, to separate these two table names, what we are writing, sir? To separate two table names, what we are writing here? Comma here, right? Comma. In ANSI style, to separate two table names, we use keyword. Keyword we write. Now this is Jan condition, sir. In Oracle style, we are writing Jan condition in which class, sir? In ANSI style, we write this Jan condition in the on class. On class, they specially designed to write Jan condition. So in on class, write Jan condition in ANSI style. To separate these two table names, we use keyword. Because of this is equigen, for equigen, use the keyword inner Jan. Inner Jan. And writing inner is optional. Shortly you can write Jan also. So here we write keyword here. To separate two table names, we write keyword here. If it is inner Jan, write inner Jan. If it is left outer Jan, write left outer Jan. If it is right outer Jan, write right outer Jan. If it is cross Jan, write cross Jan. These are keywords. Based on the type of Jan, keyword will be changed. This is equigen. For equigen, use the keyword inner Jan. Is it compulsory to write inner, sir? Not required. Shortly you can write Jan also. Inner is optional. For clarity, I'm writing inner Jan. Equigen is inner Jan. Right? Jan condition in the on class. That's it, sir. Okay. Once again, I'm telling, listen. This is Oracle style. How to write in ANSI style? In Oracle style, to separate two table names, we write comma. Comma we write. In ANSI style, to separate two table names, we use keyword. Keyword we write. For inner Jan, use the keyword inner Jan. In Oracle style, we write Jan condition in where class? In ANSI style, we write Jan condition in on class. That's it. If you know these two differences, comfortably you can write in ANSI style. In Oracle style, we write to separate two table names, we write comma. In ANSI style, to separate two table names, we use keyword. In Oracle style, we write Jan condition in where class. In ANSI style, we write Jan condition in on class. That's it. If you know these two differences, in Oracle style to separate two table names, comma, in ANSI style to separate two table names, keyword. In Oracle style, we write giant condition in where. In ANSI style, we write giant condition in on. If we know these two differences comfortably, we can write in ANSI style. Just to feel like practice, sir. You tell me now. Both Oracle style and ANSI style. I want to get SID, SNAME, mass. SID, SNAME available in student table, alias name S. Mass column available in marks table, alias name M. First to tell Oracle style, sir. How to write in Oracle style? Tell me now. What we have to write? Select S dot SID, S dot SNAME, M dot mass from student S, marks M, where right giant condition, common column is SID. S dot SID equals to M dot SID. Oracle style working perfectly. Observe. Student details with marks details. We didn't give 1003. Observe. Because equijan is inner gen. Inner gen gives matched records only. Inner gen cannot give unmatched record. Observe. Now same query I want to write in ANSI style now. Tell me in ANSI style, sir, what we have to write? Select S dot SID, S dot SNAME, M dot maths from student S, inner gen, marks M, on S dot SID equals to M dot SID. Same output I'm getting. Observe, sir. This is ANSI style. Same query copy in SQL server, it works. Same query copy in DB2, it works. Same query copy in MySQL, it works. Because this is ANSI style. ANSI style means portable. In any RDBMS you can run. If you know ANSI style giant query in Oracle means other RDBMS softwares giants also, you know. There you have no need to put efforts. That's it. So this is about equigen. Equigen topic is over. So is it clear about Oracle style ANSI style, sir? Online students, please confirm. Is it clear about Oracle style and ANSI style? Please confirm in the chat box. Mudassir Azam. YM. I already told. Step by step I explained. If we write like this, okay, if we write like this, it is degrading performance. Here very clearly I typed in the notes. If we type like this, it works. Practically, step by step I explained. That is why whenever I am explaining, please listen carefully. This query works perfectly, but here problem is there. It degrades performance. How it degrades performance? For mass column, it is searching in student table and in marks table. In two tables, it is searching. For SNAME column, it is searching in marks table and student table. In two tables, it is searching. Time will be wasted. To save that time, prefix every column name with table name. Prefix every column name with table name. In real time, table names may be lengthy. Hyderabad branch student details, lengthy table name. Assume that table name is not student. Table name is Hyderabad branch student details. Now what you have to type now? Hyderabad branch student details dot SID, comma, Hyderabad branch student details dot SNAME. Table name is lengthy. You have to type many characters to make it short. I am using table alias. Student lengthy name. Hyderabad branch student details lengthy name. I am making short S. To make lengthy name, we use table alias. Other selectors, I can type D. Like this. To make alias, prefix column name with table name. Follow these rules. Blindly follow these rules. Give table alias, prefix column name with table name. Prefix column name with table name. To make lengthy name short, table alias. To improve performance, prefix column name with table name. Listen. This is EMP table. It has employees information. To get grip on equigen, one more example I'm taking. This EMP table has employees information. This is another table, department table. This is another table, department table. This department table has department's information. 10th department name is accounting. It is located at New York. 28th department name is research. It is located at Dallas. Like this, department's information available in the department table. Their employees information available in the EMP table. Now the question is, display employee details along with department details. This is a question. I want to get employee details along with department details. I want to get output like this, employee name, salary. If I want to get this much only, just I write like this, select E name comma salary from EMP. I want to get data from one table. To get data from one table, Giants concept is not required. But I want to get that implies department name. EMP table has department number. It has no department name. Department name is available in department table. The Smith employee working in 28 department means research. So this department name I want. Okay, employee details with department details. Smith employee is salary 800. Working in 28 department means research located at Dallas. This is the output I want to get now. Employee details with department details. This is my requirement. So these employee details are available in employee table. Department details are available in department table. E-name salary columns available in EMP table. D-name location columns are available in department table. From two tables, I want to get the data. If we want to get data from multiple tables, then definitely we have to go for Giants. Display employee details along with department details. Smith employee is salary 800. Is working in 28 department. I don't want department number. I want department name. 28 department name is research. Located at Dallas. Like this. So like this, I want to get the output. This is my requirement. Did you understand the question? Question Ardhamenda Babu. I want to get employee details with department details. So this is my requirement. Now you tell me now. This Smith working in which department? What is his department name? Smith is working in which department, sir? What is his department name? Smith is working in which department, sir? What is the department name? Research. How you are telling? Based on the department number. So Smith is working in department number 20. Department number 20 means research. Same thing Oracle has to do. If EMP table department number equals to department table department number, join them. If we join like this, we can access department name and location. Our requirement is accessing second table data, department name, location. So perform join operation now. Just now I asked a simple question. What is the department name of Smith? Smith working in which department? What is his department name? I asked. Immediately he told research. How you told? Based on the department number. So if EMP table department number is equals to department table department number, then join them. If we join like this, we can access department name and location. So to access this second table data, perform this join operation. So write join condition here. Can we write like this? Department number equals to department number. Can we write like this, sir? Can we write like this? No. Because of same name, why we cannot write like this? Prefix column name with table name. Prefix column name with table name. So what we are writing here? EMP dot department number equals to department dot department. But in real time, table names may be lengthy. To make EMP table short, I'm giving alias name E. To make department table name short, I'm giving alias name D. Instead of writing EMP, write E. Instead of writing department, write D. This is the join condition. This is join condition. Now what we have to write? Select two tables columns list. E dot E name, E dot salary, D dot D name, D dot loans. From which tables we want to retrieve? EMPE, comma, department D. Where? What is the join condition? E dot department number equals to D dot department number. That's it, sir. Simple, very easy. Tell me, sir. You tell me Oracle style query. I want to get employee details along with department details. Tell me the final query now. Okay, I want to write in Oracle style. Tell me Oracle style query, sir. What we have to write? Select E dot D name, E dot salary, D dot D name, D dot location. Okay, E name salary columns are EMP table columns. E dot E name, E dot salary. D name location are columns of department table. D dot D name, D dot location. From EMPE department D. Where? Right, join condition. What's the common column in these two tables? Department number. What is the join condition here? E dot department number equals to D dot department number. E dot department number equals to D dot department number. This one is Oracle style. Same query. I want to write in ANSI style. In ANSI style, to separate two table names, we use keyword. Because of it is equijan, use the keyword inner join. This join condition we write in on clause. Right on. That's it. This is Oracle style. This is ANSI style. This one only I'm showing. Observe here. See. Here. EMP table is ready. But there is no department table. Till now we didn't create department table. There is no department table. Observe. Table does not exist. So create a department table now. I already provided this sample tables file to you. In Google Classroom, my first upload was this one only. So in this department table creation queries are there. Below of EMP table creation queries, here these are EMP table creation queries. These are EMP table creation queries. Below of this EMP table creation queries, department table creation queries are there. Just copy them. Okay. So just copy them at SQL command prompt. In Google Classroom, my first upload was this one only. Here EMP table creation queries are there. Below of that, department table creation queries are there. Just copy those queries. At SQL command prompt, department table created. Save it, commit. Observe now. Select a star from department. Department table is ready. Observe, sir. This is EMP table data. Notice here, this Smith employee, 7369 Smith employee, salary 800, working in 28 department, means is working in research department. So what is our requirement now? If EMP table department number is equals to department table department number, join them like this. So Smith record, join with 28 department research. If we join like this, we can access this department name and location. Next employee 7499 Allen, salary 1600, working in 38 department. 38 department means sales. So if EMP table department number equals to department table department number, join them. If we join like this, we can access department name sales, location Chicago. This operation only we are doing now. Just to feel like practice, sir. Okay, everyone has to tell now. I want to get E name, salary, D name, location. E name, salary columns available in EMP table, alias name E. D name, location columns available in department table, alias name D. I want to write in Oracle style. Okay, just to test your knowledge. All of you involved in the class, tell me this query now. What we have tried, sir? Common column is department number. That's it, sir. Very good. Okay, select two tables columns list. E dot D name, E dot salary, D dot D name, D dot location from EMPE, comma department D, where common column is department number. E dot department number equals to D dot department number. Observe, sir, as per our discussion, we are getting the output. Observe. Smith working in research department, located Dallas. Allen working in sales department, located Chicago. Employee details with department details we are getting. This one is which style, sir? Oracle style or ANSI style? How you are saying? Comma is there. To separate two table names, comma is there means Oracle style. Same query I want to write in ANSI style, sir. Tell me how to write in ANSI style. E dot D name, E dot salary, D dot D name, D dot location. From EMPE, inner gen, inner gen. Shortly you can write gen also. Inner gen, department D on. What is the gen condition? E dot department number equals to D dot. Same output we are getting. Observe. Smith working in research department, Allen working in sales department. But this is ANSI style. The same query copy in SQL server, you can run. Same query copy in MySQL, you can run. Same query copy in DB2, you can run. ANSI style, portability. But table should be existed, data should be existed. There also you can run. So this is about equation. You take any number of examples, same model will be there. In real time, same model, just data will be different, tables will be different, model will be same. So this is about equigen. Equigen topic is over. I'm stopping the session here.